Emostel.
Hello everyone, you're welcome to Emostel Academy. As usual, this is your regular host, Emmanuel Kadiri. Now in this class, I'm going to focus on the laws of indices as the foundation or the very first topic to be treated in exponential functions. Okay, so now we have the first law. In the laws are in no particular order, but I just numbered them, okay, for us to just for reference, okay. So now we have the product rule. The product rule in indices, or the product law, however the case may be, says x raised to power m multiplied by x raised to power n is equal to x raised to power m plus n. Okay, which simply means that if you have something like, let's say 2 raised to power 3 multiplied by 2 raised to power 2, okay? According to this rule, since it is multiplication or product means multiplication. So since it is multiplication, what you just do is you bring the common base. This is called the base, this is called the power, okay, or otherwise the exponent. So when you have something like this, maybe x raised to power m, okay, this is called the exponent, or otherwise called the power. And then this one here is called the base. Okay, so all right. So if you have the product, this law is just trying to tell us that when we have the same base but having some kind of power, there could be the same power or different power. It doesn't matter. But as far as they have power, okay, then we have same base. So all you just need to do is to combine the two bases, okay, the two base numbers into a single base, okay. Then you take the powers, the power of this and the power of the other one, you add them up, so it becomes 3 plus 2. And so at the end we have 2 raised to power 5, okay. All right, so that is just an example. It can happen in any way. So which means if I still say something like x raised to power 2 multiplied by x raised to power 3 multiplied by x raised to power 4, okay, it's still going to be the same thing as x raised to power 2 plus 3 plus 4, or you can just add it and put it there straight up as x raised to power 9. Okay, 2 plus 3, that's 5, plus 4, 9. Okay, so that's just how it goes. So that is that for the first rule. Okay, then you might be wondering, why is it like that? It's not magic. In mathematics, x alone is still the same thing as x raised to power 1. Okay, just have that at the back of your mind. So if you say x squared or x raised to power 2, okay, or sorry, if I say x times x is the same thing as x raised to power 2. All right, then if I say x times x is still the same thing as x raised to power 3, and it goes on and on like that. So if I say 2 raised to power 3 times 2 raised to power 2, so what I mean is 2 raised to power 3 multiplied by 2 raised to power 2, okay, it means 2 times 2 times 2. That is for 2 raised to power 3. Then this multiplication comes here as another times. Then 2 raised to power 2 means 2 times 2. At the end of the day, how many 2's are we having? 1, 2, 3, 4, 5. So we're having 2 raised to power 5. Okay, so which means which is the same as the results we got here. So that is where the law came from, because if you have a base carrying the power multiplying another base to another power, okay, so if you split it to become ordinary, that is 2 raised to power 3, you make it to become 2 times 2 times 2. That's 2 times 2 times 2 in 3 places. That's the meaning of 2 raised to power 3. Then 2 raised to power 2, that's 2 times 2, that's 2 of it, okay. Then by the time you just count, we are having 5 of it, so that is equal to 2 raised to power 5. Okay, so just like we have 3 of it, which is x raised to power 3, 2 of x multiplying each other give us x squared, 1x standing alone give us x raised to power 1, okay, and so that is how 2 multiplying itself 5 times give us 2 raised to power 5. So that is how it goes, okay, and so that's how the law came to be. However, you have chosen to do it It's still all good. So that is it for the first rule. Let's go straight to the second rule. You are going to need all of these ideas when you are dealing with calculus. Okay, so it's very important for you to be familiar with handling exponential functions. Okay, now let's go. The second one is the quotient rule. Quotient in mathematics simply means division. Product in mathematics means multiplication. Okay, so now the rule says that when you have two numbers like the same base dividing each other but probably carrying different powers, okay, then it's still the same thing as a single base with their power subtracting. So which simply means if you have something like 2 raised to the power 5 divided by 2 raised to the power 3, is still the same thing as 2 raised to the power 5 minus 3, and that is 2 raised to the power 2. Okay, is it true or false? Okay, 2 raised to the power 2 means 2 times 2, and that's 4, if you want to finish it up. But that's not just that's not really what we're after. Okay, we are just after managing these rules. That's what we are after. So as we have it here, okay, let's say we have 2 raised to the power 5 dividing 2 raised to the power 3. It simply means, that is, if I don't want to apply this rule, if I don't want to apply the rule, I want to do it just the traditional way. So we have 2 raised to the power 5 means 2 times 2 times 2 times 2 times 2 in 5 places. 1, 2, 3, 4, 5. Okay, divided by 2 raised to the power 3, that's 2 times 2 times 2 in 3 places. At the end of the day, 2 cancels 2, 2 goes in 2, 2 goes in 2. How many 2s are we having? 2 of it, which is the same thing as 2 raised to the power 2. Okay, so 2 times 2 eventually is 4, which is the same thing as what we have here. Okay, so that's just to prove that this law holds true. Okay, so that is that. Now, that is for the quotient rule. So quickly we go to the third one, which is the power of a power rule. Okay, so yeah, if I'm too fast, you can just pause the video, check the notes, just digest it, then you play again and move on. Okay, all right. Okay, so if we have this, the third one, which is the power of a power rule, it's just trying to tell us that if you have something like x raised to power, let's say x raised to power, x is on its own, is carrying power. And then you now have another power, like x raised to power 5, then raised to power 2. So this is already a power on its own, like an exponential stuff on its own, and then it's now carrying power outside, an external power. Okay, so the rule says that the power will multiply. So we are going to have it like x raised to the power 5. It's going to be like x raised to the power 5 times 2. Dots here means multiplication. Okay, and so we have 5 times 2, that's 10. So x raised to the power 10, and that's all. Okay, so how do we prove it that is true? X raised to the power 5 raised to the power 2 means x raised to the power 5 multiplied by another x raised to the power 5. That's the meaning. Okay, the complete stuff here raised to the power 2 means the stuff multiplied by the stuff 2 times. Okay, 1 and 2. And then if we have it that way, we apply the addition rule to it, the product rule to it, sorry. And so which means they have a common base, x. Then you have x, and then the 5 and 5 adding each other, and then that's x raised to the power 10, which is still the same as what we have here. Very simple and straightforward. You get it? So, all right, so we go to the fourth one. Go to the fourth one. The fourth one is just the power of a product, okay? Like if you have something like, let's say, 2, let me use numbers. Let's say you have 2 times 3. This dot means multiplication. So 2 times 3, we all agree is 6, right? And then you say all raised power 2. You know, law of indices says that it is still the same thing as 2 raised power 2 multiplied by 3 raised power 2. Okay, normally, you know, 2 raised power 2, that's 4. 3 raised power 2, that's 9. All right, so 9 times 4, 9 in 4 places, that's 36. Okay, now let's see. if that is going to be the case, if you're going to get the same answer, if we say 2 times 3, okay? So just to check, 2 multiplied by 3 is 6. Then 6 raised power 2, okay? 6 raised power 2, that's 6 times 6, that's 36, which is still the same thing as what we have here. So which means that the law holds true. Okay, so as it is applicable to the scenario where we have two numbers multiplying and they have a common power, that is also how it is applicable to a situation where we have it's dividing, where we have both numbers dividing, where we have them dividing. So which means if I have something like this, I'm on the power of a quotient now. So if you have like maybe 4 divided by 2 all raised power 2, okay? 4 divided by 2 all raised power 2 is the same thing as 4 raised power 2 divided by 2 raised power 2, which means this power will split itself across the numerator and the denominator. So in that case, 4 times 4, that's 4 raised power 2, is 16. 2 raised power 2, which is 2 times 2, that is 4. So 16 divided by 4, the answer is 4. So to confirm if this law is actually true, okay, let us solve it in another way. 4 divided by 2, just a check, okay? 4 divided by 2 will give you 2. This 4 divided by 2 will give you 2, all right? Then the 2 outside, all right? So 2 raised power 2, that's 4, which is still the same answer here. All right, so like I told you earlier, we're not really after the final answer or the final answer. We are after these rules and how they can be used, how they can be applied, how they can be managed, because you are going to need them when you start, when you go deeply into, when you start dealing in calculus and of course some other aspects of mathematics. Okay, so you're going to need them, but so you need to be familiar with the rules. So what I'm really after is using some general example that you can relate with to show you the validity of the rules, to show you that these rules are real. Okay, and just for you to be able to use them when they are needed, when you are trying to do some kind of advanced level mathematics and all that, okay? So, fine. That is that for the first 5 rules, okay? So, in the next video, in another video, I'm going to explain to you how to apply the other rules that I just kept here. Okay, so until then, I'm going to see you in the next video. But please, if you're not yet subscribed to our YouTube channel, kindly subscribe so that whenever we drop new videos, you'll be updated. And if you like this video, please drop a thumb up. And it make us want to do much more videos for you and all that. Okay, you can share with as many as possible. And see you in the next video. Bye.